It is difficult to classify as either a comet, an asteroid, or something artificial. But it might be important to reach such a classification, as 6 new objects have been detected in our solar system that share Oumuamua's most bewildering trait: its ability to accelerate with no clear explanation for where such acceleration is coming from. Welcome to Infinity Beyond. Today, we're diving into the enigma of Oumuamua and 6 newly discovered, fittingly named dark comets, and the strange theories that scientists have proposed in recent years to explain their baffling behavior. Let's start with a quick recap. Oumuamua is the first recognized interstellar object to arrive in our solar system. It did so on October 19, 2017, and was spotted by the Haleakala Observatory in Hawaii. Scientists quickly noticed there was something strange about it. It was small, perhaps between 100 and 1,000 meters long, and believed to have an unusual shape, possibly a cigar or a flat disk. Its trajectory and speed made it clear that it wasn't from our solar system and would eventually leave it. The object was named Oumuamua, Hawaiian for scout or first distant messenger, since it was the first confirmed interstellar visitor, though certainly not the first to pass through undetected. Scientists were eager to study it and see how it compared to objects found locally in our solar system. But as they studied it, things only got weirder. While Oumuamua was initially classified as a comet, it lacked a coma or cometary tail, making it appear more like an asteroid. This was puzzling, especially when the object was seen accelerating away from the Sun, a trait more typical of a comet venting gas, but one not displaying the usual signs of doing so. The rate of acceleration was small, only about 17 millimeters per second, but significant enough to cause a stir in the scientific community. According to classical physics, an object cannot accelerate without being pushed by some force. Scientists scrambled for explanations. Solar radiation pressure? Maybe, but not quite enough. The acceleration was too large to be explained solely by solar winds if the object were just an ordinary asteroid. Theories about its shape came into play. Since it was tumbling and the brightness of its light curve varied, it suggested an irregular shape, a cigar or flat disk, rather than a sphere. Still, that didn't solve the mystery. If it were a comet, it should have emitted visible gas or dust. But astronomers didn't see any. That's when more exotic theories emerged. The first came from Harvard professor Avi Loeb. In a bold 2018 paper, he proposed that Oumuamua was actually alien technology, a light sail, perhaps just 0.3 to 0.9 millimeters thick and up to 1,000 meters long, created by intelligent life to travel between stars. He argued that only something so thin could accelerate the way Oumuamua did using solar radiation. Naturally, this created quite a stir. Not everyone agreed. Enter Daryl Seligman, a postdoctoral researcher at Cornell University. In 2020, he co-authored a paper suggesting an alternative. Maybe Oumuamua was outgassing hydrogen, an invisible gas that would not have been detected by the telescopes used. He theorized that the object was a hydrogen iceberg, made largely of frozen hydrogen, which sublimated near the Sun and caused the acceleration. But Loeb fired back. He published a paper showing that hydrogen icebergs couldn't survive the journey through interstellar space. The radiation from even the nearest stars would cause them to evaporate long before reaching us. Still convinced that an alien explanation was most likely, Loeb's arguments were strong enough to push Seligman to refine his theory. He eventually dropped the pure hydrogen iceberg idea, but he didn't abandon the notion entirely. In 2023, Seligman found renewed interest when working with Jennifer Bergner, an assistant professor at the University of California. She pointed to lab experiments where water ice, under extremely cold conditions and hit with cosmic radiation, released trapped hydrogen gas. This offered a new possibility. Perhaps Oumuamua wasn't a hydrogen iceberg at all, but a regular ice body that had undergone radiation processing during its long voyage through interstellar space. That hydrogen, now trapped inside, could be slowly released when the object neared the sun, causing the gentle push observed without the need for visible outgassing. Was that the answer? Or was Loeb's alien sail hypothesis still on the table? As more dark comets are discovered, objects that accelerate mysteriously like Oumuamua, the debate only deepens. Are they icy wanderers shaped by cosmic radiation, or relics of advanced extraterrestrial civilizations? For now, the mystery of Oumuamua remains unresolved. But one thing is clear: it opened a new window into interstellar science, and perhaps into something far more profound.